If you just see the slides, you will understand the concept. See here, you got the same waveform for capacitor, you remember? So this is discharging. This is charging, the equation is this for discharging the equation, because capacitor charges, discharges like this. So you got, yes, same rule. Remember this point, 0.63. Remember this equation, this is very important. Remember this one. So according to this, the capacitor, when capacitor is 99% charged using this equation, then your voltage is 12 volt. Because here I gave input voltage 12 volt. Okay. So this is very easy things. I don't think this is. And then with the function generator, we gave this waveform here. With the oscilloscope, yes. With the oscilloscope, we saw the waveform. We saw both waveform. Input was here. The capacitor was going like this.
بس انتوا تعطونا الرسم احنا نسوي نفس الحكايه.
Sorry.
Do you give me picture and circle?
Circuit? Yes, yes. Yes.
طيب ليه؟
I will give the picture of the circuit. I will give. But this lab is very important.
All tables have a circuit, right?
Yes, yes, yes. And then I will give tables also. Sorry?
Grade.
Prelim, no.
No, 3 lab, not grade. 2 lab.
No, 3 I didn't grade it.
No.
Lab 4, 5.
Yes.
I will do it this weekend.
Mariam.
Mariam, okay.
Mark.
Yes, I know you are coming to the lab.
Thank you.
Okay.
So you know
I know you.
I know you.
I know her name.
Hello, Mariam.
Mariam. Okay. Mishal. Okay. So, Shahar, I know you. Hello.
Hello,
Hi, Farah. How are you?
I'm fine, doctor.
Let's wait for some more students to join in class and then we will start.
Doctor, the final exam, what it will be?
Final exam after 1 week. Next week, I will announce for the group who has to come for the exam, because exam will be divided in 2 groups. Okay. This
After 1 week, the exam?
not all together, because we have limited capacity here.
The final exam next week?
1 week after. 1 week after next week.
Yes,
Like-
okay, after 2 weeks.
No, after 1 week. After 1 week. Okay. No.
Okay, which the lab experiments is included in the final exam?
All 6 experiments. All 6. Okay.
Okay, next week when we come to the lecture, there is no final exam, no.
Next week you will come to the campus for the last experiment. And then the next week you will come to the campus for the exam.
Okay, it will be included also in the final, the last experiment.
Yes. Last experiment is very important.
Okay, and you will do for us a review,
No,
right? No?
we don't have time for review.
Okay.
You can ask me questions during we can have an extra class on Saturday if you want, but no review during the weekdays. If you want,
Yes.
I can make an extra class on Saturday,
Yes, okay.
but that will be online. But there will be no review.
You can't make it in the campus because the lab in the campus is is more important, I think, to do with the.
Yes, but anyway, okay, we will see. Hello. Did you write your attendance? You were here today.
Yes.
Ah, your pen. Thank you so much.
You can have.
No, no.
We want
So
to,
yes,
our
yes,
attendance.
yes. Tell me.
211-409.
409
211
211
390
390. Then
392.
2.
Thank you.
You also already right?
Yeah.
Today's lab was easy.
I'm going to
Why?
circle my understand the. I mean the equations were easy, but the actual application,
What?
Everything was easy.
because there were 20
numbers.
there was 2,000 errors every time.
When you got there?
No, every time we tried to implement the circuit, the graph wouldn't work, and then the
No, it's working. It's not
Yeah,
working. There was no
Only
error.
the variables for me.
Which
The
one?
readings.
Readings. What was?
Yes.
Only one thing you have to remember. This one. Only this equation for theoretical you have to remember, and then if you see my slides, you were here during my. See this when the capacitor is charging, you saw this waveform.
Yes, I did.
You saw this waveform in your, and then if you multiply with this is your input voltage. It can be 10 volt, 12 volt, 8 volt, anything. You had 8 volt. 8 multiply this give
We
you
have
for 1
8 volt or we have 4 volts.
no 4
4
is
is the just the peak, and then
yes
the
peak to peak is 8.
Okay.
Peak to peak is 8. Peak to peak is 8. 8 multiplied by this gives 0.63. How? Because when you put T is equals to 1 into RC, I showed the tables here also.
Yes. Okay.
So when tau is equal to 1 into RC, T is equal to 1 RC, and then for my case, voltage maximum was 12 volt. Then this, if I put it here 1 RC, this will be e raised to power minus 1. RC will
Yes.
cancel with this one. 1 minus e raised to power minus 1 gives you 0.63. 0.63. This is 63%. It is 0.63 multiplied by 12 volt gives you this voltage. Then if you keep on increasing it at the end, when the capacitor is 99% charged, because you will increase it 1, 2, 3, 3
Yes.
RC, 4 RC, up to so on. Then at this value, 99% charging, your capacitor will be fully charged, and then the voltage across it will be 12 volts.
Yeah.
This is even.
Okay. Now I get.
Why you have to see the videos? I explained this everything,
I
and then this is very clear in the
I
slide.
saw the video
Here-
for the prelam.
No, see this video for today.
Yes.
I will upload it. Then this is for this equation. Remember, this is for charging. For the discharging, the equation is this.
Okay.
The discharging starts from 36%.
Yes.
Next class, I will explain this also. We will see the discharging waveform also, and then we will determine the discharging time also.
Yes.
Okay. So I don't think there is such
You know,
need-
it's
No,
fine,
it's
yeah.
fine. Yes. It's easy.
Okay, it's very easy. See the slides. I really try to, then this see charging,
Yeah.
this is charging. Discharging starts from 0.36, and how I am getting 0.36% from this
From
equation.
this
I just put it 1 RC, 2 RC, 3 RC, 4 RC up to 5, and then at 5 RC you will see that your capacitor is at 0.7%, and then voltage is 0, fully discharged.
Okay.
Fully charged,
Fully charged and
fully discharged. Then again your waveform will start like this.
Yeah.
Again go down.
Okay.
What is
Yes,
the
I
point?
understand now.
What is the point?
No, no,
What's your name?
Jaffer.
Jafar. Why you have to see the video?
No, I'm not gonna watch the video.
And next class we will do in the inductor. I will make slides for the inductor also, and then we will implement it hardware. Just you have to remember this tau, how to find tau. And what is tau?
Time
that also.
constant, yeah.
Time constant for charging, discharging. Okay, it's easy.
No, it's
Yeah,
easy,
easy. Yeah.
Okay,
Thank you.
okay. Any question if you have, you can just ask me. Okay. This was Okay, so nothing. Okay. So anyone else will come? Anyone else will come or not? How many students we have online? 27. And because the overview is important, then you will understand it. I just check. 59 students. We have only very few students today. How many online? 27, and here she's not coming. I don't remember her name. Your partner here. Hala. She's online because I have very. She's sick. Okay. Because I should have 60 students and I don't have even half. I have half almost. Just wait 2-3 more minutes. Then Mariam, how are you? Good. Yeah. Did you do it the free lab? Did you understand it? So I will explain. We have now 29. Okay, so let's start it. So today we are starting lab number 6, which is determining the natural response of RL and RC circuit. So anyone knows that what is RC circuit, what is RL circuit? Anyone from online? Okay. So first of all, what is natural response? The natural response of any circuit is the response when there is no power source attached. You remember that we were having this kind of circuits, and then for a closed one, this was voltage, this was resistance, and this was I. Here, this is the voltage source. This is the power source. But here, we don't have any power source. See here? So it means when there is no power source attached, then the response of the circuit will be the natural response. So what is a capacitor? Capacitor is, the symbol is like this, the capacitor and inductor. This is inductor. This is inductor is denoted by L, C is for capacitor. These two elements are storing and discharging the energy. They can store energy, they can discharge the energy. Okay. So first what happens is, for example, if I have a capacitor here, first this capacitor will charge like this. It has plus charge here, negative charge like this. First this capacitor will charge, and then when, for example, if my voltage is 5 volt, until 5 volt it will charge. When this is 5 volt, then if I remove this, when I remove this source, then my capacitor will give power to the resistor to work, and this will give energy to the circuit. Okay. So here also I wrote the capacitor has two energy store. This circuit has two energy storage elements, capacitor and inductor. Inductor also works in the same principle. First it will charge and then it will discharge. Then it will charge, then it will discharge. Okay. So any device, whenever there is no power source present, and then response of that circuit is known as natural response. Okay. So here what is happening is the natural response of capacitor circuit is a decaying function. For example, if you have a graph like this for the capacitor, it will charge like this. It will start from 0, and then here when it will reach the maximum value, any voltage, 10, 5, whatever is the voltage, then here the capacitor is fully charged, full charge. Okay, starts from 0. So this is exponential growth. That's why the equation is equal to V naught e raised to the power minus T by RC, and V naught is your input voltage. In this case, 10 volt. When, and then another thing. So this is time. So this charging is happening over the interval of time. Okay. So the time it takes for the capacitor to fully charge, that is denoted by tau. This is time constant. And then theoretically, this is equal to R into C. Whenever any circuit is like this, then tau is equal to R into C. Okay. If I replace tau is equal to RC here, if I put tau here, then my equation will be this. Okay. Understand? Then next. me if you have any question. Now, when the capacitor is charging, the equation derived is this one. Vs is my input voltage.
Sir, your voice is not clear.
Clear? My clear. Hello? Is it clear?
Yes.
Voice is clear now?
Yes.
Yeah, before, from where you couldn't hear me?
Yes, and this side when you start.
On this side. Okay. Okay. So I told you when capacitor is charging, then this is the behavior. So when the capacitor is discharging, then this will be like this. This is charging. This is discharging. Okay. Like this. Same way it will discharge. It's the graph is written here. And then the equation will be Vs into e raised to power minus t by Rc. Okay. So these equations are very important. So let me minimize zoom here. Now, this time constant here, this is 0.63 into Q naught means current, and then here this is discharging. I will explain you in the next slide. This is discharging time for the capacitor. This is charging time, this is discharging time. We have to measure this with simulation and also with the hardware implementation, which we will do next week. So this time constant, how we measure it? Here. If you use this equation for charging, 1 minus e raised to power minus t by Rc, if you put t is equal to 1 Rc, in this equation, what will happen? It will be Vs into 1 minus e raised to the power minus 1. Yes? If I put t is equal to Rc, it will be equal to 1 minus e. Then if I calculate this, this will give me 0.63. Okay? This is my input voltage, which is equal to, in this case, I considered my input, V input is equal to 12 volt. I also write here. This is battery, not better. This is battery, okay, I will change it. Okay, so if I multiply 12 with 12 into 0.63, this will give me 7.5. Now what I will do is, here this is 12 volt. I will move in the simulation, I will move my cursor to that value when this is this value, 7.58. Then this is my time constant. What is time constant? 90? Link. There is link. They have joined already. No, there is link. Who is saying? I have students here. Section, which section is this? Link is here. Which section is this? Section 3. Section 3, there is link. It is here. because the students are there. Yeah, this one. Lab section 3. This is Farhan. This is lab section 3 here. Okay. So what I was explaining. Okay. So what is time constant? Why I am determining the time constant? Why I am interested in this time constant? What is it? This is the time which tells us how long the capacitor takes to charge and to discharge. This time constant will tell us how long the capacitor will take time to charge and to discharge. This time constant will tell us. That's why we are interested for the time constant. If the capacitance value is higher, then the charging time constant will be higher, will be bigger. If the capacitor value is less, then this time also will be less. Capacitor will immediately charge, immediately discharge, immediately charge, immediately discharge. If the value is high, then capacitor will take long time to charge, long time to discharge. Okay. Then if I put T is equals to 2 RC, then this percentage will be 13.5, and then if I multiply with BS, then 1.62. This is for the discharge here. This is for charging. So for the value of T is equals to 2 into RC, this value is equals to 86.2, and then if I multiply it with 12, I get this value. It means capacitor is 86.2% charged. Then I will change it to 3 RC, 4 RC, 5 RC. Then at 5 RC, I will see that my capacitor is 99% charged, means my value is almost 11.92 volts. It means at 12 volt, when VC is equals to V input, means 12 volt is equal to 12 volt, it means that capacitor is fully charged. Fully charged. Okay. Now when the capacitor is fully charged, what it will do? It will start to dissipate. So how? I remove this. Now my capacitor is fully charged. Now it will start to discharge. How? Now my equation is Vs e raised to the power minus T by RC. I will do the same step. E raised to the power minus 1 will be equals to, because T is equals to 1 into RC. This value. Minus 1 will give me 0.36. This value. The capacitor is 36.8% discharged. Then I will change this value to 2 RC. Then it will be 13.5% discharge. And then if I multiply it with 12, I get this value. Okay, then with this multiply by 12 will give me this value. Okay, so this is my discharging time, and then I will calculate it for the first one. Then it is equal to 1 into RC. This time constant I will determine. And first cursor is at 12 volt. And the second I will change it to 4. Here my value is 4.42 volt for 1 RC. Now this is my tau, which is equal to discharging time. Discharging time. You got it? Yes? Here? So this is very important tau. In this lab, we are just calculating the charging and discharging time, but you should know the theory behind it. Okay, that's why I'm explaining this. So, and then these equations are very important. And then these equations are important. For discharging, this is the equation. For charging, this is the equation. Okay. We will implement these both equations today in the lab, and then we will see that how to determine the tau and how to use this equation to determine the value for the time constant in simulation and then theoretical. So next, this also I explained. Now, what we will use here today? We will use function generator. What is a function generator? What? What?
Second one.
Yes.
It is a signal source, miss.
Sorry?
It is a signal source
Yes.
for the capacitor.
We will use this function generator. The function generator gives us different type of waveforms with different type of frequencies. We can take sinusoidal waveform from this function generator. We can get square waveform. We can get triangular waveform, and then we can get sawtooth waveform. Any kind of waveform this function generator will give us, and then we can change the frequency of these waveforms also. Okay. And then the range of the frequency is from 0.01 hertz to 100 hertz. Then this we will use in today. Then we will use oscilloscope. What is oscilloscope? Oscilloscope will give me the measurement of my signal. For example, if my circuit is some small circuit with capacitor and resistor, and then from function generator I will get input. From function generator, I will get input, any input, 10 volt, 5 volt, 4 volt. From function generator, I will get the input, that will be the AC input. Then, here, from here, if I put one terminal of oscilloscope here, this will give me the input graph. And then if I connect the another terminal, here, this will give me voltage at the capacitor. Voltage at the input, voltage at the capacitor. It has two channels, channel 1, channel 2. Okay, so this is oscilloscope gives me the graphical representation of my electrical signals. Okay, what is the benefit of oscilloscope? Why I see my signals in oscilloscope? The benefit is that if there is any problem in my circuit, I can fix it. If I have a complex circuit, and if I see that there is the waveform is not correct or my circuit is not behaving properly, I will connect oscilloscope at that point and check if the elements are giving the proper result. Then I will replace the element. Okay, so these are the benefits. So here I connected oscilloscope here for this one, and then this is channel 1, and then this is channel 2. So this is channel 2, channel 1. So I can see both waveforms on same oscilloscope at the same time. Okay. So then this is your pre-lab. I think this is not clear.
Doctor, this slide, can you upload it in Moodle?
Yes, I will. So you see here, when we will simulate it, then we will see this waveform. This is 10 volt because I gave input 10 volt, and then this is capacitor waveform. You see here, from here, this is connected with first channel, then grounded. Here, this is connected with the capacitor. It means this will be my input voltage. This will be my capacitor voltage. Okay. So input voltage is this one, which I will give from function generator, and we will choose square waveform. 10 volt is my input voltage, and then capacitor, you will see that capacitor starts to charge. Okay, you will see it today. And then another thing is, what are these voltages? What is VP, peak voltage? Peak voltage. If you have this kind of waveform, sinusoidal, any waveform, this is VP, peak voltage, and this is minus peak voltage. For example, and then if this is 5 volt, so what will be my peak voltage? No, peak. No,
-5.
yeah, this will be -5, yes. So what will be my peak voltage? Peak is here. This is peak. What is peak? When you go to a mountain, 0 is the peak or the upper point is the peak? So mountain is starting from 0. Where is the peak? Peak is at the high point. So this is peak, 5 volt. What is peak to peak? 10. Yes, 10. How? This peak plus this peak. V peak to peak is equal to 5 minus 5. 10 volt. So I will give from the function generator only peak value, but my output is equal to 10 volt. Why? Because output is peak to peak. 10 volt. What is RMS? Root mean square value. For example, this is the effective value. This is Vp divided by square root of 2. The effective value of this waveform is VRMS. What does it mean? What does RMS mean? The value which is visible in this sinusoidal waveform is the RMS value. I think in your theory also you will understand. But RMS, for your understanding, the effective value inside of sinusoidal signal, inside an AC signal is the RMS value. The effective, which is visible. Okay. Peak is this. Peak to peak is sum of these two, and RMS is the effective value, which is equal to V peak divided by the square root of 2. Okay. So clear? Let's
Doctor, can you repeat the last one?
RMS.
Yes.
RMS is the effective value. I can give you an example. What kind of electricity we are getting here in our house and industries anywhere, offices? The electricity is AC, not DC. It's AC. But if you calculate the average value for this sinusoid, how we get the average value? These are a bit advanced concept for you, but okay, I tell you. Your electricity is sinusoidal, okay? If I ask you to calculate the average value, how you are calculating average value? For example, for this one, V average is equal to 5 plus minus 5 divided by 2. What is the result? 0. But still our lights is on. Why? This average value is 0. We should get no electricity, but we get it. Why? Because of the RMS value. Because the scientists then studied that we are getting the electricity because there is some effective value of the voltage due to which we get electricity, and that value is RMS. That is equal to Vp divided by square root of 2. Okay. So let's. Is it clear to you?
Yes.
Concept of V peak to peak RMS. Yes. Okay. Then let's implement this circuit today, and then we see that how much is the charging time for a capacitor, and how we calculate the charging time constant. Let's do it today, and then I will guide you. I will help you. Okay. This picture is not clear. Any questions? Any questions?
No.
For me, Miss, I did it, the pre-lab. And
Okay.
actually my results, it's making negative. I don't know why. Maybe there is something wrong in my program.
Okay. Let's see. I can show you the steps here. think this waveform will be more clear. Is it? Yes, now this is visible. Is this visible now? Yes. First do the multisim because it will take long time. If we have time, we will implement it on hardware. Otherwise, we will do it in the next lab. Also, we have to implement inductor in the next lab. So first build this circuit. And then let's calculate the transient time. Let's calculate the charging time. And we'll come to you one by one. So, okay, who was online, who was talking to me because they wanted to share the screen. I don't remember the name. Yes? Who wanted to share the screen?
5 minutes, miss, and I
Ada.
will share.
Okay. You didn't come to campus
Yeah,
today?
I have fever, miss.
Ah, okay. So, what? First implement this one. Yes. Yes, I will give you this for the I will take the next class because there is a equation for capacitor and then for the resistor and yes, make this one and then for this one also try to calculate the time.
Yes, can I share now?
1 minute, just 1 minute.
Okay, miss.
Yes. Yes. Okay, okay, now see this. 0.16 multiplied by input is A4. So we need to substitute 0.04. Now move your cursor to 5.04. 5.04. Okay. Now check this time constant. This is 0.147 milliseconds. So if you multiply correctly, then tau is equal to R equivalent into C equivalent. So R is equal to 1,000 multiplied by 0.1 into 10 to the power minus. Now in here it is 0.2. How much is it? 0.2. Okay, 0.2. So then this was not 8, this was 10. So we choose 5. This is 6. Move your cursor to 6. So this will give you 0.2 milliseconds. This is correct. 6.3. And then check this tau 204.74 microsecond. It means 0.2. This is simulated tau. This is correct. What is this? Simulation tau is this is what this for us. Change it for the I. One thing I want to clear up.
Doctor, I want to share my screen.
Yeah, in 1 minute. 1 minute. Take one is power success. One is power.
Let's So you can have here is the cursor. I mean the RC, right? So yeah, how much you can compute? No, that's one. It's a tau RC, so if I need 0.2 milliseconds. So if you take it as a 70, so they said, okay, so now we take it from, so the maximum should be here. Then second cursor down. No. So the voltage at this point, cursor 1 is going to give us channel 1 and channel 2. So channel B, we can 2.23, 4.03.
And multiply it with this, and then my capacitor charging
from that,
yes,
60% of that. And then
I move my capacitor point, check the charging time.
from the target from here.
1 millisecond. Did you make it?
Yes, yes.
So you make it down? Down? Yes?
So now you're gonna find the value. So it will give us like here, 9.50. So say, so here it will be V, here the V out equal, that's one. So 9.2. So if we have 1%, 1%, so as an investment here, so you have a session. The exception final times 0.62. So for example, the exception final here times 62. Right? Just
I know, I showed already here. No, not every time. You have to, you can change. I know. So every time. Yes, channel A. Now. So how we can break down? Now is equal to
So
one
yes. How much you find? 0.2. And we get 0.005.
Then this is correct. How we get it from simulation? There's the same result. So we use this equation.
Because you need to add this from 0 to the top or from 0. Starting when it is up to the point of 0.63, right? So this is so what is this? I have to check the time in the equation. Time is 13. And let's say 13.004, right?
I will move my cursor. At the moment it is 5.3.
So it's not what is the antigen time. The time
Okay,
is
so this is
229 means family what is it? And it's almost the same answer. And then they ask yeah,
now take the value. 0.2 and then change according to that. Okay. Then what will it? And then you same. I show you. 1 minus this one. This one. So 1 minus here is 1 minus RC by RC 1 minus 1 minus 1. This gives 0.6. So this gives 0.63. when P is equal to 1 into RC, it will be cancelled into or minus 1. 1 minus e to the power minus 1 will be yeah, for the 1 it's not t is equal to for 1, it will give me 0.0. When I put t is equal to 1 RC, I start from 1. Yes, because I put if I put 0, it will be 1 minus 1 0. That's why I put 1. I will start from 1 to 0. So, minus 1 minus 0 is 1 minus 1. We have to give. Okay, so give me no, I don't know. This will give me this is like C and tau. This is C. Tau is tau I will calculate from the graph. See here, tau. So okay, now this is equal to 0.0. Okay, now 0.6. Multiply by how much is your input voltage? This gives me 5.0. Yes. Give me 5.0. Now I will take my cursor. Okay, 5.0 is okay. Then check this. This is equal to 1.
Miss Madia.
And 1. Okay. It's this one difference. This time minus give me this difference. And then this is equal to yes, you will change the voltage here to 5. You will change 5, and then you will change this point, and then calculate same circuit, just change the and then how much age? The second 6.2, and for the point 2 you have input voltage 10. Then you change your yeah, but they go, yeah, from here you know that peak to peak is peak positive peak. Okay, okay, if you are still there, okay, then okay, then how much? 0.63 See, now R equivalent 0.2. calculate the theoretical value. 1000 multiplied by 0.2 R equivalent into C. Tau is R. This will be 0.2 millisecond. Then, and then this will be same 0.2 because you're into voltage ratio. It's 0.3 by 0.2. Now take this side. Take a screenshot so that you remember. Take a screenshot for the Yes, online students. Did you understand how we calculate tau?
Yes, Miss, can I share?
Yes, yes. Yes. All the students, please see, I will repeat this procedure for you so that you understand. Okay.
I don't know why it's giving me minus.
Can I take your control?
Okay.
Now choose from here cursor.
Okay.
Show cursors and then change it to white. Okay. Now this is yes. So let me see your see here you connected with the negative. You have to connect it with positive.
With the positive. Okay.
Yes. Remove this. Remove, delete. Connect it with the positive. Okay. Now. Okay. Actually, I want to see directly from. I don't know why this one is coming. I want to see result there. Okay, anyway. Take it here. Because here the result is okay, 7.9. Actually, I don't want this one. I want to see directly from here. Can you rebuild this circuit without simulation, without doing this simulate thing?
Without the simulation?
Yeah, without this. Because I want to see directly the result from here.
Yeah, okay, I will do it now.
This I don't want.
Miss Madia,
just make another file and then copy this circuit there, and then I will do it. I want to see it from here so that I can exactly map the cursor.
Okay. Now
Okay.
I will do this. Okay. Thank you.
Yes.
Miss Maria, I want to share my screen. I do the pre-lab, but I don't know how to check the
Okay.
values graph.
Share. Okay, so first of all, change this to positive. Oh,
Which one?
this first one. Delete. Yes, delete this file.
You should stop first this.
Okay.
Yeah.
Delete this
Okay.
file and then connect it with the positive. Yes, positive. Yes. Okay, now let's check this values. Yeah, here to change it to square, and then frequency is how much? 625 hertz. Duty cycle 10, and then this is 4. This is 4. Then now change it to and then now move this cursor. Okay, now see here this can you see my mouse? This is your
Yes.
input voltage. You gave V peak voltage equals to 4 volts. Now this is getting peak to peak voltage, which is equals to 8 volts. Okay, I explained it during my lecture. This is peak to peak voltage. Now I will change this cursor number 2, because 0.63. Okay, I explained this also here. Ah, this is yours. I thought this is my computer. Okay, so okay, I write here. My input is 8 volt. Okay, you know that.
Doctor, I can't see the screen, the board.
Can you open Zoom and then you will see?
Yes, I'm opening it because I'm sharing my screen. I can't see a screen.
This is for. Can you open your? This will give me 5.04 volts.
Doctor, if you are talking with me, I can't see.
See your screen on Zoom. See your screen on Zoom. I wrote there.
No, nothing.
I think she has to stop sharing. Then you will share, Miss.
Yes.
No, this is her screen. Not.
Yeah, this is her screen. She has to stop.
I don't know if she will be able to see it. Okay, anyway, I will move my second cursor to 5.04. So 5, now this is at. It's very small time interval. I don't know why. Wait a second. Okay, it's fine. But very small interval. So then this is my tau. In your case, I cannot map it exactly at 5.03. It's very, very big.
Channel 1 channel 8. Constant V.
Yes, we input.
Okay. But so we see about to channel B, right?
What?
We see the channel B.
Yes, we see the channel B. Channel. What is channel B? Channel B is the capacitor voltage. No. Channel B is the capacitor voltage. See here.
Yeah, the V. Oh, okay.
Capacitor voltage. See, channel 1 is connected here with input. Input is coming here. Input voltage is with the channel A.
Okay.
And then here this capacitor voltage, it is connected with channel B. So channel B is giving us capacitor voltage. Channel A is giving us the input voltage.
Okay, when you put this here,
But this, yeah. Run.
okay, gives you 8 VB.
Yes.
Yeah.
This is input.
Okay. Now, when you change this, okay, the value of this, like
I cannot change because when I will start, this will start to charge. This will start to charge. Initially it will
So
have
it
0
will-
volt.
okay, so it will change the VB here.
Yes.
Okay.
No, not V peak. It will only change. The input will remain the same. Here
No,
you are
but with
considering
me, it changed.
it changed with the passage of time.
Yeah.
If I put it here, then maybe it will change.
When I change the value, it's another value.
It shouldn't change V input.
No,
It goes to 0.
no, not it's higher. 9 points.
No. 1 minute. Not because of capacitor. It changed because of the input. You will change the value of power according to the equation. Now your voltage input voltage is 10 volt, 10 multiplied by 5. We tau is equal to the input into 1 minus 0 minus 1. The input is peak to peak voltage. Input. This will be 1. It's here. This is 10 volt. 10 volt is your input peak to peak. In function generator, you get the value dp only. This is dp. Peak is okay. Half of 10 volt. Right? Now this will remain constant. Input will remain constant. Here we count. Then now input is your 10 instead of this it will be 10. So 10 multiplied 160 will give you 6.2. So 6.3 yes, it remains. Yes, Now you will change 10. 10 multiplied by 153 is equal to 6 points. Change your percentage.
Yeah, it's almost like 0.1. So that means that it will be 10%. Right. But even then, you have only one. I got it from the maximum. So the maximum is 0. Then try to reduce it to 61. 61.8. So we can say that it's going to be right.
This was for 8.
But if you want to do that, that's what you're going to have to do. So if you make that one, you can minus this, you can apply to 0.0.
Yes.
So
Now this is 0.1.
Now here, it should be 1 microsecond, but yeah.
One cursor at 10, other at 6.3, other at 6.
Yes. So you should do that. And you should not so you want one it's 1 and when you have the register, it's 1 so yeah, how to collect it.
It's meaning of 0.19. No, why?
But the simulation,
0.199.
simulation is said that it's
So now, so now I will take the circuit. Yes, ma'am. And at once. And at 2.
no, I didn't have it.
For only for this.
We'll verify that P equals
So we just This is the charging time.
Now you are good. So this one.
Factor which I use is 0.1 microfarad. 5.1 microfarad, the charging time is 0.1.
Small time when we.
Because the capacitor value is what we concluded. Yes,
And now what we do, change the treatment.
and then take it out. Both are theoretical and then just there is a pricing one.
What overstood.
I have
So when you have, if you want, for example, given our case, it's a British transport, but in this case for the inductor, so that's why we need to apply, you know, the variable, so that you know, voltage inside but you should define it from the district.
okay, just take it out and then when people
So yeah, try to, I don't want to share video now.
maybe knocked out 0.1 millisecond. Good. Take screenshots and then put in the report. But we will complete it in the next. Because we next step. Why? Okay. See here, this equation, see here. Is equal to B input 1 minus E raised to the power minus T by dot. Okay. So this gives you 0.63. Okay. When P is equal to 1. Then input is equal to in your case how much?
Okay, guys, good luck.
10. Then we have because 5 kV substitute to take it 10. Close it. There is no submission history. Yes, okay. So for online, Farah, your time is very less. I don't know why.
Okay, doctor, how I can fix it? How?
Let me. This is not 0.01. This is 0.1 microfarad. Maybe because of this. Okay. I don't know, your time is very less. Did I check this? 6258?
Yes.
Okay. This is very less time. I don't know why.
Doctor,
Yes.
to the report that I will do, what I will submit, I should take a screenshot
This
of
week there is
it.
no submission. This week no submission.
Okay.
So let me. Yes, I will take attendance. 1 minute, Farah. I will stop sharing your screen because I want to take attendance.
Okay.
But I will fix. Yes. 10,
2020.
20, 4, 8, 10, 2012, 2012. Did you understand?
7.
2012, 17.
7.
Yes. Okay. Did you understand? Okay. So what's your ID? No. 19 2 002. This one 97. Okay. 97. Okay. Yes. Mariam, what's your ID? 20 2014. Yes. One 132. Okay. So anyone else online? Farah, if you copy this circuit and then paste it on new multisim, then I think your problem will be solved.
How?
Just copy like this and from here make a new file and then paste here. Then I think your problem will be solved.
Yes, but I can't copy it from yours.
Copy all the circuit. Copy all the circuit, then I think your problem will be solved. Offset is not working. No, Abdullah, I will take your attendance from Zoom. It's fine. Okay, so Mariam, done. So for online student, for Farah, please copy it in another file and then redo all the steps. And today there is no submission. So we will repeat this lab next time with inductor. Okay. And then also we will implement it on hardware. Okay. And then after this lab, after the next lab, there will be final exam. And there will be no review. But if you want review, then I can give you, I can make a review on Saturday. But it will be only online.
Yes, but next week we can't come to the campus and there is also lecture.
You want to come to campus?
Yes.
So you can come to the next class. Come to the campus on next class.
Okay.
Wednesday.
Okay, doctor, this is the final exam, not a quiz, right?
This is the final exam, final lab exam.
Yes, okay.
This is the last.
Doctor, it will be online.
In first 1 hour, we will finish the experiment because we already did the simulation. Next class, we will only implement hardware. In 1 hour, we will finish, and then next hour, I will give you the review. Okay? We can try to be quick with me next.
Okay, Miss, did you take attendance?
No, I will take it from Zoom. It's okay. No. After 1 week, you will have final exam. After last, and then next week exam. Yes.
Do you know what date will be?
Okay. So, for example, today is 8. Today is 1. Next is 8. 15. You have final exam. Okay. 15th
Miss,
Wednesday.
Which experiment is going to come for the final exam?
All 6. All 6.
Doctor, it's gonna be online.
It will be in campus. In campus with hardware. You have to use hardware for the experiment. Okay.
Not multi-sim.
Tell me your student ID. Yes. Yes. Did you understand the experiment?
Yes.
Well,
70%.
Why 70%?
I try to increase it.
Okay.
Okay.
Next class you will increase it. 20.
211.
211 654.
Yes.
And what's his name?
Ali.
Ali. What's your student ID?
That one.
But you're Ali.
Yes.
Who is he?
Roshni.
Roshni. What's his ID?
201.
201
274.
274. Roshni, did you understand?
Yes.
Good. Okay, so please remember that on 15th of December, you will have your final exam. Next.
We will do circuits and also multiple, right?
Yes.
Okay. All
6.
or one of them.
2 experiment I will give.
2 experiments.
2 experiments.
And you will
So,
give us the.
but this AC part is very important.
That one.
Yes, this one. This is very important. So you should know that the principle behind charging, discharging of inductors and capacitor. You should know the equations. This is very important.
But the law you will give us, right? The law.
Which law?
Like RC.
Yes,
The tau is
yeah.
RC.
I will give the circuit. I will give you the circuit. And for example, if it is superposition, I will say you, okay, solve this experiment using superposition theorem. Then you should know the steps for superposition theorem. See my lecture slides because I explain all the steps in the lecture slides. Maybe both, maybe one. I will select any students for the hardware. So, yes.
Okay, so some students wants to do the hardware. Okay.
I also don't know anything now. I will think on the weekend about your exam. Okay? To make it very hard. Mariam, you can do it. Okay, so next class we will try to finish the experiment in 1 hour, and the next 1 hour we will do the review. Okay, so that we don't engage ourselves on Saturday. Okay. Okay, the class is over for online students. Please try to solve this lab. There is no submission this week, and next week you will submit your report. Okay, done? Okay, so stop here. I end the meeting for online. You can leave the meeting.
Okay.
Yes.
Doctor, this is for the second.